Hi, everybody. You might be here because you're a little lost on the nomenclature still, so I'm going to give you one last review. Okay, the Odd Nomenclature podcast is named the Odd Nomenclature podcast because I'm dealing with the odd nomenclature problems that were assigned in class from the cumulative review sheet. So if you're having trouble identifying what type of compound you're looking at or writing formulas and naming them, then you're at the right place. So hang on to your seat and go get that worksheet. Make sure you have a pencil and a periodic table in front of you. And if you don't know those ions yet, you really should learn them, but you might want to have your polyatomic ions in front of you. All right, periodic table, polyatomic ions, and your handout. All right, big eraser doesn't hurt. Now, the correct answers to this whole odd worksheet are going to be posted online, so watch for these. All right, so 5 types of compounds that we've been working on naming. First of all, ionic compounds. Ionic compounds, when you're looking at the chemical symbol, you're going to see a metal first or an ammonium ion first. That's the NH4 1+ ion. And that's going to be followed by a monatomic anion or a polyatomic anion. Now, the monatomic anions are going to be something like sulfide, fluoride, chloride. The polyatomic anions, sulfate, chlorate, on that sheet that you have in front of you, hopefully. In terms of the naming, a dead giveaway is if there's a Roman numeral there, bam, it's probably going to be an ionic compound. We reserve Roman numerals in binary covalent compounds for the stock system, and we're not going to try to trick you there. We'll always tell you that's a stock system. If you're looking at the elements, though, once again, you'll be looking at the name of a metal, and you're going to be looking at the name of an ion, either monatomic or polyatomic. Now, when we write formulas for these, we have to balance the charges of the ions, and that's what some people find to be a little bit complex, especially where the polyatomic ions come in. Now, there's binary covalent compounds. Binary, of course, means 2. Covalent means covalently bonded. So if they're covalently bonded, that means the electronegativities are rather close to each other. So you have a low electronegativity difference and you have a covalent bond. There's sharing of electron pairs. So how do you tell if you have a binary covalent compound? Well, you only have 2 elements since it's binary, and both of those elements are going to be nonmetals or maybe a metalloid. In terms of the names, all of the names, every single one of them is going to end in IDE, where the second element is concerned. Now, occasionally you're going to see ionic compounds that end in IDE too, if the metals are bonded to a monatomic anion or peroxide, cyanide, or hydroxide. So you have to watch for that, but you should be able to determine the difference between those by now. But the IDE, if you have 2 nonmetals, boom, binary covalent compound. Binary acids, 2 elements. The first element is always hydrogen, and then hydrogen's either bonded to a group 16 or a group 17 nonmetal, and there's only 7 of these. Now, these are the classic acids that you've probably been familiar with in your educational career. They always start with hydro. This is the only type of acid that we have that starts with hydro, and they always end in ic. Not hypo and not us, just hydro and ic. Ternary acids. Ternary acids, again, are going to start with hydrogen. However, they're going to be followed by a polyatomic ion, which contains oxygen. And that's why we have a synonym for these ternary acids that is called oxyacids. They contain oxygen. All right, so these guys here are named from the polyatomic ions from which they're derived. So the polyatomic ions are going to bond to the hydrogen, and if it's an 8 ion, an ion that ends in ATE, then the acid becomes an ic acid, IC. If, however, the ion ends in ITE, then the ending changes to OUS. Now, the last group of compounds that we talked about in class were the simple hydrocarbons. And the simple hydrocarbons are going to have 2 elements. And they're hydrocarbons, so it's hydrogen and carbon, but the order is reversed. It's always carbon followed by hydrogen. So if you looked at a hydrocarbon and you thought perhaps it was a binary covalent compound, stop. These are two specific elements, carbon and hydrogen, so therefore they are hydrocarbons. These hydrocarbons can form chains and they can form rings. When you're looking at the name, all of these names for our purposes are going to end in A N E because they're all single bonds. They're called saturated hydrocarbons. Some of them start with cyclo, some of them don't. The rings start with cyclo, the chains do not have a prefix. Now, here's what we have. We've got really bad pictures of your table. And I had to cut it off this way because I couldn't fit it in. I do apologize for the quality of the pictures, but it's the best I could do. So I'm only going to be naming or writing the formulas for the ones that are circled, but I do want to go through on some of these and I want to determine what type of compound they are. So ammonium nitride, it starts with ammonium. This is an ionic compound, so you'd mark it IC. Cyclooctane starts with cyclo, ends in ANE. This is a hydrocarbon. Barium sulfide. Barium is a metal. Bam! Ionic compound. Hydrofluoric acid. Hydro and ic. That means there's only two elements in this acid. This is a binary acid. Aluminum hydroxide. Here's a metal. Automatically, you assume that it's an ionic compound. Sulfurous acid. There's no hydro in front of it. It ends in OUS. It's got to be a ternary acid that includes oxygen. Iron 2 bicarbonate. Here's your metal, so therefore you have an ionic compound. If you go to the next column, this guy's a little tricky. This is acetic acid. And I have the structural formula for acetate written, and when I do that, I always put the hydrogen last. So this right here is going to be a ternary acid. It contains a polyatomic ion. HI, two elements, starts in hydrogen, and then we have a group 17 element. That's a binary acid. Two elements, starts in hydrogen. Look for the hydrogens to start with. Hey, here's ammonium, NH4, and of course the charge would be 1 plus. We don't see that, but we know that that's ammonium. That's an ionic compound. And then there's our buddy tartrate. Starts with hydrogen, polyatomic ion. This is going to be a ternary acid. We have two nonmetals right here. That's going to be a binary covalent compound. Now we have two nonmetals. However, the first one is carbon. That means we have carbon followed by hydrogen. It's a hydrocarbon. And then we have a metal and a polyatomic ion. So this is an ionic compound. All right, so when you're taking your test, you can divide these up into groups if you want. I see some things here that are hydrocarbons. I see some things that are binary or ternary acids or binary covalent compounds. So what I'd like to start with here, and hopefully we'll get to one of everything, are the hydrocarbons. Most people seem to have those under control, so I'll just mention very briefly what those hydrocarbons, or how those hydrocarbons are named, and how you can write the formulas for them. If you see cyclo in front of a hydrocarbon, what this tells you is that your ratio of carbon to hydrogen is always going to be 1 to 2. Okay, and you have to look back at your notes because the stem right here, oct, tells us how many carbons. All right, so if it's octane, it would have 8 carbons. So since there's a cyclo in front of it, though, we know it's a ring, and we're going to have a ring of 8 carbons, and then every single carbon is going to have 2 hydrogens off of it, so this is called octane. All right, over here, we have another hydrocarbon. And we have 6 carbons, so that's going to have the stem hex. I know this is not a ring because the ratio of carbon to hydrogen is 1 to 2 plus 2. And so it's not a 1 to 2 ratio, so therefore I have a chain. And so I'm just simply going to call this hexane. Hexane. And so that's how the hydrocarbons work. Now, the binary covalent compounds tend to be fairly easy, and I'm just doing one slide at a time here. I know I'm skipping around, and I am doing even ones on this page, so you just have to be tough. On this binary covalent compound, it says N2O3. Binary covalent compounds, that's where we have prefixes once again. Now, they're a little bit different than our hydrocarbon prefixes. The first 4 are mono, di, tri, and tetra, whereas the hydrocarbon prefixes, the first four are meth, eth, prop, bute, or monkeys eat peanut butter is a way to help you to remember that. And then it goes pent, hex, heptoc, non, dec. So when we're looking at this, we have two nitrogens. And so I have two nitrogens. I use the prefix di in front. And so this is going to be di-nitrogen. And I'm trying to write neatly, di-nitrogen. And it looks like it's going to be trioxide. Trioxide. Okay, we've got 3 oxygens. Now, please note that the ending here, the ending changes to IDE, but the first element actually is going to remain the same except for that prefix. All right, so make sure that you change the ending of the last element to IDE. And sometimes you use the complete name for the element, sometimes use the first symbol, sometimes use the second symbol. And the only way that you can really learn to do this is just by doing it and comparing your answers to the right answers. So on the next thing I want to do here, the binary acids that start with hydro and end in ic. All right, so all you have to do is you simply would pretend that this is an ionic compound, and you know hydro stands for hydrogen or proton, so the charge on that is 1 plus, group 1, and then fluoride is in group 17, 1 minus. If you add up these charges, we balance them out so that we have 0 as our total charge, so we have 1 hydrogen and 1 fluorine. Same thing over here. This is a binary acid, and I know it's binary, 2 elements, starts with hydrogens. So I know my binary acids are always going to start with hydro, and then the stem, in this case the stem is IO, and then it ends in an ic, so it's hydroiodic, and I'm just going to put A right there. Okay, so the next thing I want to move to are these ternary acids. The ternary acids are based upon the polyatomic ions. Whenever you see an OUS ending, that means that the ion from which it's named is going to be an ite ion. So if you know the formula for sulfite, you're in good territory here. We've got SO3 with a 2 minus. This 2 minus is really important because that tells us how many hydrogens are going to bond to the sulfite to give us sulfurous acid. So sulfurous from sulfite, 2 hydrogens, reflects the balancing of the charges, and there's the sulfite ion. We have another ternary acid over here, and this is tartrate. Tartrate's a little bit different because we changed the name up some. Practice these and you'll learn them. So the tartrate ion makes what we call tartaric acid. All right, so this is frequently used as a leavener. Snickerdoodle cookies use tartaric acid, and it's also an ingredient in baking powder, so you all probably have it in your kitchen. We need 2 hydrogens here because the charge on the tartrate ion is 2 minus. Now here we have acetate. Okay, this is acetic acid. Here's my acetate ion. It has a charge of -1. My hydrogen comes last. Okay, so this is acetic acid. Now if you have the acetate ion written in the other form, the non-structural form, you would put the hydrogen first. This is a way to write the structural formula. And so if you ever use this part of the, if this formula for the acetate ion, you'd follow it with the H. Okay, so that leaves us with the ionic compounds here. And the ionic compounds, we have to name the ions. So, or we have to look at the ions and put the formulas in this case. So here we've got NH4, 1 plus for ammonium, and nitride is going to be monatomic because it ends in IDE. So I have 1 nitride with a charge of 3 minus, and I have 1 ammonium with a charge of 1 plus. In order for these charges to balance out, I have got to have 3 ammonium ions. I've got to have 3 ammonium ions. So my end formula is going to be NH4 in parentheses. If I have more than 1 polyatomic ion, I put it in parentheses. I put a 3 on the outside, and then I'm going to put my nitride right there. Barium sulfide, number 3. Barium is a group 2 metal, Ba2+. Sulfide, IDE, monatomic, S 2 minus. And you can see if I've got 2 plus and 2 minus, that those will add up to 0, so I get one of each.